Yeah, so this will be Dr. Conador shortly, and he will be joining us at Headcount. So it's very interesting what he's doing with the scripting language, so very good, Connie. So I'm going to be talking about the need for converging 3D imaging and building information models. And we can kind of see the need from Dr. Frederic Brochet's presentation, who's one of the co-authors here with me. He and I are doing some research and some collaboration together. But we have a deeper vision of an open system, okay? And also cloud-based and things like this. So we're kind of short on time, but I should get through this fairly quickly. So first I'll introduce our focus, and then speak of the need a little bit, and then our proposed cyber-physical system. So don't let that go over your head. I'll try and break that down in layman's terms. And also the cloud-based and openness of this solution, and really our vision, which we'll get into, which is pretty unique. So basically, our environments, our built environments lately are becoming more cyber-physical. There's a huge need for us to have a link between virtual world and the real world. So how do you go about that? So laser scanning data affords us the ability to have the captured data of as-is facility data, all right? So what's actually there in the virtual world, so that allows us a metric to go by, something to link to with different technologies. RFID tags, GIS, and things like that. Then we have the physical, so that's the physical world, and then we have the virtual world, which is the actual BIM model. So we want these two to talk to each other, right? So that's kind of the point of some of the part of the solution we have. So virtual to real is the reality change, which isn't our primary focus. So you could see cyber-physical systems, maybe perhaps by Penn State's department, PhD department in architectural engineering, where they're working on cyber-physical systems in this area. But we're more concerned about the reality capture, the real to virtual. So scan to BIM and scan versus BIM, which was mentioned earlier. So for reality to virtual, it demands capabilities in both building information modeling and in reality capture, such as 3D imaging, and in this case specifically terrestrial laser scanning. So when I say TLS data, that's what I'm speaking about. So that's the laser scanners that you saw in Connor's presentation, and perhaps I think Leica's out there in the lobby, so you should be familiar with this. And then the two main processes involved is real to virtual. So you do not have an existing as designed BIM, okay? So that's very significant, as Fred pointed out this morning, that you need the design BIM. But so part of this is, how do we go from the point cloud to a 3D model? So some people think that scan to BIM is going from the scan to a 3D model, but that's not actually true. Scan to BIM is going from the laser scan data into a semantic rich model. And the majority of current research, the semantics is there, but it's more like depth, width, height. Is it a window versus a door? We're talking about a deeper semantics here, such as fulfilling the requirements of IFC parameters and things like that. So a little bit further than just height, depth, and width. And real versus virtual, the Scanner Bim process, where you do have an as-designed BIM model. And you're registering your point cloud with this model. And it's affording you to contract what was constructed is per the design for the owner. So that's very important. And you do this during the construction of the facility. You don't have to wait until the end. So it affords many opportunities there. Which is tracking the progress during the construction, and assuring the accuracy of the as-built BIM model is accurate for handover. So the industry wants to speed up design and construction processes with technologies and make it a leaner approach, but we don't want the technologies to disrupt the integrity of traditional approaches. So it's a push and pull there. So make design and construction processes also more efficient and interoperable. Validate what the owner once was constructed. Accurate handover as is and as built models, so there's a difference. As is maybe a facility that's already there, created into a BIM model versus a as built model, which is when you actually have updated your design BIM to an accurate model for handover. And also reduce the cost, waste, project duration, these other things, lean concepts. So real to virtual and virtual versus real are in high demand in our industry. So especially in complex environments like this here. So in this image here, this is the Corona Brewery in Mexico we're currently designing. So you can imagine if we had the laser scanners out there tracking what's being built is according to what was designed, and you're assured a proper as-built model straight away for handover versus waiting until after the construction and then doing the scanning and validating the model. So that's one example of maybe perhaps tracking the construction process, but in a very complex environment. So this is different than your average facilities, right? So 2 examples here of real to virtual. So scan to BIM, so TLS data to a IFC semantic rich BIM model. So here is a as-built BIM from a commercial building here in Dublin, Ireland, where we're actually using scan to BIM processes to assure a as-built for handover, because we want the owner to be able to have the COBie data with it, right? So a semantic rich model, not just a scan to 3D BIM, which doesn't afford you to utilize model view definitions, information exchanges, and things like this. So then here's an example of as-is BIM in a pharmaceutical plant here in County Dublin. This one is. And actually, this is for a design retrofit, okay? So they needed a model. So in this kind of environment, folks are actually being paid to make wooden boxes at night and see if they fit through corridors. So if we wanted to move this object here highlighted in blue, which they would actually make a box that size and see if it fits and do what if scenarios like that versus virtually. So here we could actually make semantic rich models, or perhaps sometimes we don't even need the semantics in the model for these cases for design retrofits. So at the semiconductor facility in Leakslip, we're actually doing what Dr. Fred showed us this morning, scan versus BIM. And it's very important in these complex facilities to assure that what's being built is according to the design for many, many reasons. So is what was constructed according to the design BIM? If not, how do we handle these issues? What do you do? And what are the deviations and tolerances allowed? So sometimes we might not need to move the valve because it's within the tolerance, and that's okay. Sometimes the valve's not there and we need to populate a valve. So you can see the picture there on the right, which shows it's pretty close. It may be within tolerance, so that might be an issue where we won't have to actually fix the model perfectly. But the deeper vision here is having some of these things be automated. So this process here is very subjective. So you sit 6 guys down, they go through this model the size of a football field with 1,000 of very complex objects, and they're going through and navigating and trying to find and highlight things like this in red. But we envision an open source system that will allow you to automatically find these things and then generate reports. So we'll move on. So a big problem is existing software do not integrate with collaborative BIM processes and do not feed into the BIM model. So this is a need for cloud-based solutions, okay? So these software systems are more like, Fred refers to them as black boxes, and I agree, limited to customization of specific needs of specialist applications. So a need for open solutions. So it's difficult to go into the API, or you actually go into SDK kit of Revit if you want to create a plugin. But it afforded a person like Connor a better method using the open source software where he used GDL, okay? So that shows an example of why you would want to not use a proprietary, even though that software is proprietary, it's affording him better, it's enabling him to go ahead and create these objects on his own without being locked into the proprietary SDKs and things like that. So open solutions afford the same thing. So the results of the problem are these tasks are very time consuming, they're manual, they're costly. So this pharmaceutical plant in County Clare, on the left-hand side, the model is not as per the point cloud, okay? So it was very time consuming for us to fix this because they needed us to fix this for FM handover, okay? So a system's needed for visual identification of the deviations, which we mentioned, and we envision a viewer that supports open point clouds and also open BIM model formats, okay, keeping it open, this philosophy of openness. Reporting the deviations, so the statistical reports. Obviously, you can see here the two flanges are not meeting in the model, but the scan shows they are. So we want automatic reports that this exists in this huge model and not have to find it, and perhaps we don't find it. And then that leads to further issues, right? So support the correction of the BIM models as per the TLS data. Okay, so this is very important to understand. Fred's scan versus BIM methodology can be enhanced in different ways. So we envision the model actually being able to fix itself as per the as-is point cloud. So in this case, that model should be able to talk to the point cloud, right? A cyber-physical system where those flanges, after the problem is recognized, that it will go ahead and deform, so a deformation algorithm that will make those flanges within tolerance to the T, right? So you define these tolerances, and the algorithm will sort out the problem for you, basically. So our proposed system is to manage BIM and 3D imaging, okay? That's on the surface level, that's quite obvious now throughout the talk. And so this cyber-physical system supports these two criterion, but in a non-proprietary form, right? So we want it to be open. And we want to use open source to speed up innovation. This is a key here. So imagine both academia and industry working together to build this system, okay? And I'll talk a little bit more about this as we go on. But then also a cloud-based system that supports efficient and collaborative processes, okay? So a single cloud-based virtual and real system that is open source, which allows everyone to add at free will, okay? And also allows the bidirectional interoperability between the virtual and real worlds. So you can envision this as the viewer, the cloud-based, open source BIM server. Okay, so Leon von Berlo spoke. I use his BIM server for lots of software development applications, and this is a perfect example of where you can use this type of open source tool and modify it for yourself. But then also have it hosted on the cloud and a customized viewer that supports E57 point clouds and IFC BIM models. So we want the cyber world and the virtual world, the cyber virtual world and the physical real world to be able to talk together. So have that bidirectional interoperability. So virtual to real, reality change, and then also real to virtual. So the value of cloud-based solutions, BIM processes / technologies are friendly. So perhaps you can envision what people have been talking about as BIM level 3 being cloud-based due to all this data and things like that versus running them on their local machines. Cloud-based solutions are very powerful. No need to have computers in every office. Centralized repositories for storage, reducing data redundancy. And AEC companies should be focusing on AEC problems, not IT problems, okay? So the value of open solutions, currently poor interoperability is a major barrier to BIM development. So we need to dissociate content from format, okay? And we choose to use the standards that are open here, E57 and IFC. So this is an example of a system I created for the Army Corps where I used the BIM server, a customized viewer to do lead certification review in a virtual environment, a database in the background that supports COBE, RS means cost data, and all these multiple dimensions that we can go ahead and all link together. And this is afforded by all these open solutions being able to be linked and talk to each other. So some of the ingredients, the BIM server, Cloud Compare, Mesh Lab, IFC Open Shell, the open source point cloud formats, point cloud libraries that are open, linked to the system, the game engines that are open source, other standards like CityGML. So our idea is a core software platform for the industry that is open source. So we share each other's contributions to a robust software platform. Plugins, okay? So imagine everyone's working on this software system together, globally, academics, PhDs, master's students, and the like, and then also industry. So you can create your own plugin, all right? Which leads to, open doesn't equal free. So, and also commercial doesn't equal proprietary. So you can use an open source system and create your own commercial software. So if we create a proprietary plugin, maybe that's not afforded to the public, but the viewer is. And maybe someone like a PhD student wants to create a plugin, and then you can maybe get that on GitHub or something like that. And if you want to learn more about this, you go to the gnu.org, which will explain the licensing. So this is rapidly growing in industries of, I'm running out of time here, but biobricks, okay? So basically DNA segments, components that allow people to actually work and solve problems in their garage. So synthetic biology actually going on in people's homes and their garage. They're solving problems quicker. So schools like MIT and schools in London are now getting together and joining this initiative. So the AEC can do the same thing, right? It's working in synthetic biology. Imagine it working in our field. So we envision cyber-physical BIM bricks. So BIM bricks. One BIM brick maybe being a virtual world brick, okay? And then the real world bricks. And allowing people to work on these bricks like Legos, so to speak, but they're semantically rich, and innovating them over time so we can solve problems quicker as an industry together. So imagine a BIM brick standard that's similar to what does exist, a BioBrick standard, okay? And to round it up here in conclusion, our vision is an open source cyber physical system, BIM bricks, living in an open source software platform, perhaps the BIM server, maybe not. We haven't totally decided, but the BIM server definitely affords us this opportunity. The platform will enable the convergence of the virtual and real world utilizing open standards. So IFC, we might not use IFC in the future, but the system can always grow, and if something overtakes that standard, implement it as well. And then the same with point clouds. So imagine the automatic generation of IFC models from the point clouds, creating as-built models directly from the point cloud that give you these handovers. So maybe you can see the correlation with the mandate BIM level 2 and the as-built handover Kobe, and being able to do this straight away on historical monuments that do not have design BIMs, okay? And also imagine the model being able to fix itself, okay? So BIM to Bim. So using this point cloud, an IFC model, and some mathematics going on in the background, but when you press a button, it does the math and it finds, oh, the valve's out of tolerance and fixes itself. Oh, the pipe needs to be moved. A window's not there. I need to go from the library and populate that window. So we aim to develop these cyber-physical BIM bricks in the near future that allow bi-directional interoperability between virtual and real worlds. So I hope you're able to understand some of this or all of this and see how open solutions can really help us move forward in the industry, and innovation can take place at a much faster rate. So thank you.
Thank you very much, Shawn. Well, we are obviously running a bit late still, but are there any questions for Shawn?
When do you think it happen? When will it? Is it time to?
Okay, so recurrent, was this turned on? Go ahead. Check, yep. Okay, so we actually have funding from EI for this. So Enterprise Ireland has already accepted lock, stock, and barrel, no questions asked. And my company's willing to fund, and perhaps some other entities will want to contribute. And basically what Fred and I need is a stable software platform, okay, with the viewer. And once we have that, we can start working on these BIM bricks and dimensional control compliance plugins that allow companies to find the valves automatically, find the pipes automatically, fix them, not the subjective process that currently exists in some of these organizations where we're having to navigate through the model and find them and get subjective results. We would like mathematically proven results, reports, highlights, models fixing themselves. So basically it's a little bit of a funding issue, but it's coming around. Some of this lives at Harriet Watt, some of it lives in Headcount offices, and a little more contribution, and we could start making this available to the public.
One question.
Since it's open source, how do we, let's say tomorrow I want to contribute, right? Not money, not financially, obviously. I want to contribute on how maybe to solve things. How do I get involved on that? If I want to, for example.
So, yeah, so are you familiar with GitHub or open source?
I'm actually familiar with open source.
Okay, yeah. So imagine you download the BIM server, like Leon Von Berlow's bimserver.org, but in this case you go to GitHub and you would download the cyber physical system BIM server with the viewer that allows this, and then you have the source code, and then freely at will, anything you can think of that a problem you're trying to solve and some algorithms you are working on, create a graphical user interface, just a button, and allow that source code also open to the public, form a group, people will contribute. There's PhD students all over the world wanting to, or they are doing this in different ways, but in this particular topic, it's not afforded to them yet, but we envision it being there, and you can have the code and you can experiment with it. Does that answer your question?
It's kind of, but it's okay. I understand it.
Okay.
Okay, once again, thank you, Shawn.